Okay.
Recording and
Oh, this makes me so sad. Anyways, okay. Hi everyone. I'm Maggie, and this is Yash, and we're here to teach you guys like circuit construction and how to use like the breadboard for your uses. Oh, we start like straight with them.
tell me in the video to this. We can talk about these two. Yeah.
Which one?
That's right here.
Are we gonna turn on?
Yeah, it's already on. Yeah, I can switch over. Okay.
Okay, you want to start? Okay, so we're gonna just open the box. We're gonna open the box and we're just gonna see like what's inside of it, and I'm gonna explain how like some of the components work and stuff like that.
Right.
Okay, where's the box? Where is the box? Oh, it's laggy. Okay.
It's a little laggy.
So here's the box that you have, the circuit construction box. Inside, you should open it up. Unboxing. Welcome to my YouTube channel. And inside you will get like a ton of like components like this. All these components. And then the wires. Oh, sorry, I don't see what you guys see. The wires. Oh, right here. Right here. No, it's right here. Right here. Right here. Yeah. So the wires, which is going to connect to your breadboard, more wires, and then the breadboard, the actual breadboard, and then like a pocket breadboard. Right. So this pocket breadboard, to me, is very useful, especially when you go into your classes. When you go to like circuits 1 and circuits 2 for their labs, because rather than buying the big huge board and bringing it around, you can just bring this tiny one and plug stuff in, and you don't really need that much components in the earlier classes. So this is like the perfect size, right? Okay. So how does the breadboard work? So inside the breadboard, you have, well, it's already in there, but the breadboard is detachable. You can take it out of the pocket breadboard. You can put it in. So you should have 2. So if you want to switch your breadboards in and out, whatever. And then these are like the screws. The screws where you put your cables in. So you have these cable wires, right? Let me counts. So here. Okay. So you have your cables, and the end of the cables they have banana pins.
Mhm.
And these can go directly into the cables like this, or the clips. Right? You can stick them into here really nicely. So, and they're very hard to like take out, right? In the lab room, like when you actually go to the lab, you can actually stick these into the big DC supplies and stuff like that as well. If you look closely inside these connectors, and if you actually unscrew it, they're basically just metal. So metal connection with metal will conduct from one side to the other. So because of that, if let's say you don't have these banana cables, right, you can use the alligator clips too. So these are the alligator clips. They have like teeth like alligators, right? And then you can just clip it onto these clips like that. And since the metal on the alligator clip touches with the metal inside that we saw earlier, then the conductivity will work. Okay. Okay. You want to talk about the breadboard?
Mhm. So every breadboard looks like this. Let's see, it's up there. Okay. Oh, there we go. Okay. So you can see that there are actually rows and there's columns in the center base here. You have rows from 1 through 30, and then you have columns from A through E, F to J. So, and you also have 2 more columns here that go straight like down plus and minus, and then plus and minus on the side. And how this connects is actually each individual row in the center is connected together in the center. So if you look inside of a breadboard, it looks like this over here. So you can see, say, row A or row 1, and so A through E is just one large wire like that. So each of these individual rows from A through E, which is like basically 5 pins, will cut together. So you can cut up to 5 different things together in each of these rows. And so you can cut over and over. And then these plus and minus right here are bus lines, which means that they come from all the way from up here to all the way down here. So that you can connect your main power and ground. So power being plus, ground being minus throughout your entire board. So you make sure that you never want to connect the same component to the same row, because that'll basically just put the same voltage through both of the pins, right? So an LED does not go into the same thing. It'll go across rows in a column. That makes sense? Okay. Also, it's called a breadboard because originally the very first breadboard was actually built on a board that you cut bread onto. So that's why it's called a breadboard. And they actually stuck nails, and then they put wires through these nails to create the first ever breadboard.
Wow. So cool.
Yeah.
Okay. What should we do next? This is here. Okay, so the other stuff you have is like, so these are switches, right? Oh, you guys can't really see, but this one is a switch.
Slide switch.
Yeah, the slidey switchy. So it's like the ones you have over there, but instead of just going like this, you're like switching it up and down, right? And these are push buttons. These ones are push buttons.
Too high.
Oh, wait, they're here. They're push buttons, so you could like click it and it turns on or turns off depending on when how you wire it and when you click on it. And Yash will explain this more when we start using them. This is a diode, and this component, basically what it does, it only allows direction to go one way. It's very blurry. I know it's very blurry on the screen, but if you look closely, there is a line. It's like gray, and that will tell you whether or not like which direction it goes to. So Yash is kind of drawing the picture. Wherever that gray line is, that's where the direction is supposed to go. So it can only go from positive to negative and never negative to positive. That line is basically telling you that it's a wall. So nothing can go through it, right? And then these are capacitors. Oh, these two are. These two are capacitors. They're like the circle things with the 2 wires. This one is a larger capacitor. The larger the capacitor, it has like the larger the size is. And for these are very similar to the diodes. Only this one though. So these ones are very similar to the diode, as it can only go one way, one direction. On the side, it has the negative sign pointing to, oh my God, you cannot see. It has the negative side pointing to the arrow, to which wire it is. So the shorter wire is going to be the negative, the positive wire is going to be the longer wire. All right. And these are going to store energy for us, when we plug in our power. If we don't, so let's say we charge up the battery, at the charge of the capacitor, and then we take the power supply away, it starts to discharge that energy inside the capacitor, right? And same thing with this thing. It's the same thing. However, it doesn't matter which plus or minus it is not polarized. Therefore, you can just put it any way you want, right? We could talk more about these. I'm assuming you guys kind of know what these are. These are LEDs, which you're going to turn on and off depending on how much current you flow into. Similar to the diodes, these are polarized, meaning that there is a plus and a minus. Right? So if you were to connect a plus and a minus the wrong way and flip it, then it won't turn on no matter how much power you put into it. The positive is going to be the short side, and then the negative is going to be, wait, no, the positive is the long side, and then the short side is the negative, right? And it's kind of the same with the capacitor as well. The capacitor, if you look at it, it's going to be short being negative and long being positive, right? Let's see what else. Oh, we can talk about these ones later. Okay, and then I guess we can talk about this last one. If you guys have gone to the workshops before, we use this one a lot. All right, and what this one does is that you can put a wire into these little pins in here and screw the top of it so that you're gonna keep the wire from sticking in here. Instead of sticking it directly onto the the wire into the breadboard, you can connect it through this. And you will see that we have a circuit provided to you guys later, and you guys can see how to use these ones. And then this is a potentiometer. Oh God, not see. But basically the potentiometer, all it does is that it's a resistor that can change its value. And this is a resistor right here, right? A resistor, what it does is that it prevents current from, or it limits the amount of current going through a system. So let's say if you have the LED lights, if you put too much power into it, it will blow up, right? And you don't want it to blow up. So you would put a resistor in front of it or before it, and then you could prevent all the high power to go through our LED lights. We didn't talk about the wires. Oh, you want me to go?
Yeah.
You talk about the female.
All right. We also have in our kits, we have these jumper wires over here. So you can see. And all right. So there's 3 types. We have the first one being our male to male, which basically means they'll go from one component to the other, has these little pins right here to insert between 2 components. So see our breadboard over here, you can push one in here and put another one in here. That's for like those components over there. We also have a this is male to female. So sometimes we have header pins on, let's say, the Arduino or something else, right? Which already have component things coming out. Let's say you need to take, you don't want to cut the LED itself onto the breadboard. You want to kind of jump it out, right? It already has these pins already on there. So what you can do is you can put an end of the LED into like one of these jumper wires over here and put it into the breadboard. That way you basically extend its original pins. And then we have female to female over here, which is just to connect 2 different components that have leads. So like, such as like say a button and an LED. So you can put the diode to the LED kind of thing. Okay, we also have these component gauges for you guys over here. All right, yeah. So this helps you cut off any excess wires from the resistors or LEDs, so that you can put them into the breadboard without any extra wires on them, so that they won't like stick out, so they can just be clean when you guys make your kits. So there's no rat's nest. So what you want to avoid is a rat's nest, which is basically when you have all these long wires all around the breadboard, so you can't actually make sure that your circuit is actually nice and neat, or you can't, it makes it harder to debug. So these component gauges over here will help you cut off any excess wires so that you can actually make a nice clean circuit that looks aesthetically pleasing, but also helps you debug your circuit. Something else that you guys may have in your kits as well is actually these right here. If you guys came to our circuit or soldering workshop, you guys might see these as our 555 timers. So these are just timing integrated circuits. So they have little tiny circuits within these, this black right here. Huh? It's just a timer circuit. Yeah. So basically, after you connect one of these with a few resistors and capacitors, you'll get a clock frequency. So like it will oscillate from on and off. And that is how a lot of things that we do, like with electronics right now, that's how they function. Like your computer will function using a clock signal to do a work that is like storing memory or to write something else. So this is basically a very, very crude version of your computer or a clock signal in a way. So you can create your own frequencies this way. This can actually, you can create a lot of different things like let's say you want to make an LED turn off and on at different, maybe different, fading at a different time or something like that. Like a light, yeah. So we have this as well as these small little things here. You can see these are called transistors, which are basically electronic switches. So you guys have seen these push buttons, right? And then you have to manually do it yourself if you turn off and on with your human input. These turn on with an electric signal, but they do the same job as a switch. So a lot of the logic or how your computer computes and everything is through transistors. So they turn off and on different things based on conditionals, like if this and that kind of thing. So this is called a PN2222 resistor. It's one of my favorite transistors, not resistors, sorry, transistors. It can help control some really small motors, a lot of like different switches. It has a small max current, but it can do a lot of things.
I think that we did everything in the kit, right?
I think so, yes.
Yeah, okay. Okay, so now we're gonna go pass around like different things. Okay, what color box do you guys want? What color you want? Red?
So what we'll pass right now are these 9 volt to 5 volt, 9 to 3 volt. These are like, yeah. These right here are going to be your voltage regulators. So what they do is they convert from a 9 volt battery, which is down underneath here, into 5 volts to be used for a lot of the logic we're going to be using today, as well as 3.3 volts for anything else. So we want to talk about
black.
Okay.
I don't even know this is a black one, to be honest. Let's see. A gold one? What color do you want, Alex? I don't know about that. Blue. Oh, here we go. All right, what are you saying? Yeah, so in this system or in this block that we but I feel like we can't see.
I'm gonna try to fix that right now.
Okay, well, while you do that, I'm gonna check with you. So in here we have the battery inside of your box, and then you also have things that turn on and off, right? So it's gonna be red like this. So whatever the text is on here, it's gonna be like yeah, just read it like a normal person, right? And so on this side, you have your battery connected into the circuits, and this is how you turn it on and off. So if you're facing it this way, the left one is going to turn on and off the circuit, and you can see that it uses an LED light to tell you if it's on or off. Right? And then if you guys got one that doesn't work, please let me know, and then I'll give you guys a new one. So does everyone's turn on green? Yeah, green. And so there are two different switches. One is going to be, if you read the text right here, it says 9 volts, which is the battery. And this one is going to output 5 volts. Right, 5 volts is this one, which is the blue one. And then 3.3 volts, which is the orange one. Is orange? Yeah, the orange one. So depending on how much voltage you want. So for example, where did it go? For example, this 555 timer uses 5 volts input. Oh, sorry. The 555 timer uses the 5 volt input, right? So when you want to power this 555 timer, you would have to use the 5 volt pin and wire it to this 555 timer. If I were to directly take this battery, which is 9 volts, and plug it into this 555 timer, it will start heating up and it would be like smoky. So it's basically putting way too much power into your circuit, right? Good.
So voltage and current matter a lot with what we do here for electronics. Just because if you put the wrong voltage in the wrong device, it will cause an explosion or a fire something. I accidentally put 20 volts into a device that only requires 5 volts. That was not a fun sight. The entire thing exploded in a large pop sound and large spark, and it just the entire top part of whatever it was just flew out in the air, and it never functioned ever again.
In your room?
It was luckily not in my room, but it was actually I was showing somebody else our Liquid 3 when I first made a prototype of it. So I had all the chips on the breadboard and it caused an explosion. And I was really excited to show them too. And they're like, so that was something.
When you're demonstrating too, that's great. Yeah. Anyways. So yeah, so today you're gonna be using these stuff, this power supply to power up our like circuits that we're gonna build today. All right. Okay. And then let's see. What is this? Wire strippers?
I believe so.
Okay, so these are, you can show this one.
All right. So we also have for everyone, let's talk about we have these wire strippers over here. So these are automatic wire strippers. They're pretty easy to use. In case you guys need more wires, these jumper wires aren't enough, you can always use some actual normal 22 gauge wires. So these are solid core, which means that their internals are solid. So if I were to just use this and put it through and click on it, you can see, you grip it, but
Can I show the video for this?
the video for this?
Yeah. I don't think there's a video.
We can show it a little bit.
After?
Yeah. But this is solid core, so you can see it's all solid. There are other types of wires too called stranded. Because there's like basically small little strands of wire instead of the solid one, they can carry more current through it, but they're also a little bit hard to work with for our purposes. So
okay, let's build a circuit.
Okay,
we're gonna build a circuit now. All right.
the first one.
Huh?
The first one.
Just the basic. Okay, so the circuit we're gonna be building right now is going to be a basic turning, like just a resistor and an LED circuit. So you have so in circuit form, like if you look at a diagram, this is what voltage looks like. So we're gonna input 5 volts in here. 5 volts in this, right? So that's the top part. And then we're gonna add a resistor and then the LED light. Right? And then this is ground. Or this is the negative side. So again, this is the positive and this is the negative. You can remember that because this line looks like a wall and things can't go past this wall when you're going this way, right? The arrow is going to point to you where the direction is going. So this wall, think of it as this part right here, right? And the resistor value, it will limit the amount of current going through your LED light. So if you have a high value for the resistor, right? Then you're having less current going in, so it should be like the light should be a lot less than like a resistor value that's a lot lower, right? And we'll try that out very soon. And then we're gonna try out this one to be 3.3 volts too, to see how changing the value of the power or the voltage affects our light.
Great. Also for symbols, setting for a diode, you just put a little arrow here. And this is what an LED looks like for our schematic here. All right. And this theory, where we talk about the resistor here to reduce the current flow, is using Ohm's law. So that says that the voltage equals to current times resistance. Okay. So you see, if our resistance, we have a resistance value here, right? And let's say you have a current. Right. What is right? 5 volts. And then we have resistance. Our current has to go down to make sure that something stays.
Yeah. So let's see. If we have a voltage, our voltage is 5 volts, right? And let's say our resistor value that we choose is 1000 ohms. Right? So I times 1000 ohms. That means with basic math, you divide both sides, right? And then I is going to be equals to what?
0.005.
Yeah, I'm straight. Right.
And then if they only 10 for our resistance value, then the current will skyrocket up to like.
Right, yeah, so if our resistor value, so this is a very high resistor value, right? And then if we have a low resistor value like 10, right? Then we get this to be 0.5
amps. So 500
amps. There we go.
That's just 500 milliamps.
Right, so earlier we had 5 milliamps, which is 5 times 10 to the negative 3. And then now we have 0.5 amps. So this is like a lot bigger than this one, right? So that's the math behind it. Okay, let's build a circuit.
Does that make sense? Or...
Oh yeah, 3:30. Okay. All right, let me just. Okay, so everyone get your breadboard out. All right. Oh, I got red and red. I didn't even notice. Okay. Anyway. All right. So first things first. First things first. What? Let's see. So you have the power supply, right? We're gonna use the 5 volts right here. Can you guys see? Should I zoom it in? No, I guess it's fine. This is the 5 volts again, and this is the 3.3 volts, right? So we're gonna put this on the side. When you're building your circuit, don't really mess with the voltage yet. Don't put power yet until you finish your circuit, right? So on the breadboard, you have plus, right? And then you have minus. Plus and minus. So we're gonna use that as our reference. So we're gonna plug in plus here and minus here, right? So let's see. We're gonna start off with the resistor value. What resistor values do we have? So pull out your bag of resistors. Right. Oh, you want to give them the wire cutters?
Yeah, how's that? We don't need wire cutters. Oh, we do.
There we go. Okay, so let's start off with the lowest value first. In everyone's everyone's bags, which one is the lowest one for you guys? 330, right? So normally 330 is used in very common LED lights like convention. So normally you want to add 330 to your circuits, like normally. So let's take out a 330, and to pull it out, you're just gonna like yank it out of the sticker thing, right? So now I have my resistor. Okay, so let's see. I'm gonna bend the wire like this, right? And you guys can see that you guys can just put it in the wires anywhere, you know, just like stick it in somewhere. Huh? Yeah. So this is a very big, like it looks kind of messy, right? Especially when you have a ton of these. If you have a ton of these, it's gonna be like very wobbly and it's not gonna look that nice, right? So this is where this comes in. What is this called again?
Component gauge. The
component gauge. So what you're gonna do is you're going to stick the resistor through this, this is big enough. Through this big hole distance one. Yeah.
The top one.
The top one. Put it in the top one. Oh my god, blue is not a good color. Hold on, let me.
Podcast with that one.
Blue. Is brown better? Let's see. Brown. Oh, brown's even worse. White? White. Yeah, snag it.
Yeah.
Oh well, whatever. Okay. All right, so you have the white one. I mean, you have whatever color you have, and you put it inside the top part. So what you're gonna do is you're gonna hold it, and you're gonna get your wire cutters. Everyone has one, right? A wire cutter, wire stripper, wire cutter. Yeah, and you're just gonna cut it at the bottom. This is basically like a reference for you, like a skeleton, right? And now when you put it inside your circuit, it's a lot cleaner, right? Now I can't like flick it or anything. It's very clean. It's in the board, right? Oh, it looked like I just slapped it. Okay. So now we have the resistor, right? So we want to connect the positive to one of the ends of the resistor, right? So let's take a male to male connector. Male to male is the one that has like the pins. Right, can I like unangle this? All right. Okay. Did everyone take out their jumper wires? Yeah. Take out the male to male. And let's take two colors. So normally in circuits, the red color indicates the positive side. So I'm gonna take the red one and I'm gonna use it as the positive, right? So what I'm gonna do is I'm going to find one of the plus on our circuits. So the plus side over here, I'm gonna plug in our one end, right? And then on the other end, I'm gonna plug it to the same row as the resistor on one side, right? So I have the resistor on line 14. And then depending on the number that you guys put it on, it should stay on the same connection, right? And now we're gonna get what's after the resistor? The LED, right? Okay, now take your favorite color LED. What's my favorite color? What color is easier to see? White?
Yeah.
White.
So
Okay. Blue?
You have a lot of.
Okay, I'll do blue. All right. I have blue. I took blue, but you guys can take any color you like. Right? Again, I described that the long side of the LED light is positive, and the negative side is going to be the short side, right? So based on the circuit that we just drew, is the resistor connected to the positive or the negative side? The positive side, right? Therefore, which side should be connected to the resistor on the breadboard? The long one, right? So to make your connection easier, what I like to do with the long side is kind of bend it. Give it a little arc like this, right? A little nice arc. This way, this way, this way. I like to have a nice arc to it. Right? And then based on the way the breadboard works, right? How do I connect this long side of the LED light to our resistor? Will I do it, let me see. Will I connect it on the same column? Or I guess it's this way. On the same column, or do I do the same row? Will I connect the same row or the same column as the resistor? Same row? So the same number or same letter? Right? Okay, that's right. Because again, on the back of the breadboard, all the wires are connected horizontally, right? Like this. So whatever you connect on this side is going to be the same over here. The conductivity, right? So let's plug this in here. Okay, there's another thing I forgot to note. So this short one is the negative side, right? I don't know if you guys can see. Yeah. So the short side is the negative side. Where on the breadboard can we directly put like this into on the breadboard? Yeah. So since we have to put it on the same row, right? And then the negative is right here for us. Oh my God, we can just stick it in there, right? There we go. So the connection is going to be, if I follow the path, right? The positive voltage goes into the wire and goes to the resistor, the first end of the resistor, right? Which is what happens. The voltage goes into the resistor 1. Going out of the resistor is connected to the positive side of the LED light, which is this one. Oh my God, you guys, this one right here. And then it goes through the LED light and then into the negative side of the LED light to the negative row, right? So for power to work, you have to have a full loop. As you can see, nothing is open, right? You can't really stick your hand in there. Everything is going to be closed off, right? So now this circuit is ready to plug into your power supply. So again, we have your power supply. And what I'm going to do is I'm going to take 2 wires. I'll take a white one and an orange one. So orange is going to represent the positive, and then the white one is going to represent the negative. All right. So inside or on your breadboard, or I'm not on your breadboard, on your power supply, this is the 5-volt pin, all right? The top one. If you look closely, you can see positive and negative on the breadboard, or not. Why do I keep calling it a breadboard? On the PCB, right? There's the positive side and the negative side. So what I'm gonna do is I'll do positive first. For the positive, I'm gonna stick it through the hole, like in here. And then screw it in. Do we have screws?
No.
That's okay. Yeah, you can pass the screw around, I guess. And then you're gonna screw in. I think I have a screwdriver in my backpack too. I don't know. I need to look. Here, you want to screw it?
Yeah.
Here. Here, I'll screw it. No, fine.
Yeah.
Okay, don't you have the screwdriver too?
I left it at home.
Nah. Wait, I don't know the spits though. It's like the one I got from the career fair.
Oh. Yeah.
Let's see. Let's see what fails. I guess it does. I didn't. That your power supply should be off when this is happening, but you could, okay, but whatever.
Oh God.
Hello. Oh, you need it. Or did you just think it?
Yeah. Yeah. You're already.
Okay. Alright, let's.
Yeah, I thought you were
Okay. So following the positive and minus, right? This is the white one was the negative, and then the orange one was the positive, right? So where you see the positive, you plug it into the positive, and where you see the negative, you plug it into the negative, right? And one last thing is that I'm going to connect both of the sides together, right? So I'm going to use one wire to connect the negative and the negative together. And then I'm going to connect the other one, the positive and the positive together. You need a screwdriver? Yeah. Thank you. It's okay. All right. Okay, let me see if it works. Oh, I didn't turn it on.
You put positive.
Oh, there it goes. All right, turn it on. I forgot to turn this on.
Oh.
All right. So normal practice, basic practice is to have your power supply off when you're building the circuits and plugging the wires in. But there is a switch here, so I guess it's fine or whatever. All right. So let's turn on the actual power supply. And then once we turn the switch on, your LED light should turn on. Does it turn on? Does everyone turn on? Does it turn on? Does yours turn on? Yours doesn't turn on.
Oh, that's fine.
Okay, yeah, so what happens here is that you want the resistance to be the same row as this LED.
You just, so, you need to put the positive part, the positive. Negative. How will you correlate positive?
So now the connection between the resistor and the LED light. The rows. When you turn it on. Okay, cool. So now we're going to. Okay, now we're gonna turn off the power supply. So turn it off. Right? And now let's take a 10K resistor. Right? Or actually, no. I lied. Don't turn your system back on. Turn your thing back on. Okay. So now what we're gonna do is that you're gonna measure the voltage, right? So oh yeah. Okay, so how to use the multimeter. So what a multimeter is it's gonna measure the voltage. So earlier we did this math problem, right? So at this point, you're gonna always have from here, if you take two probes from here to here, this part will always be 5 volts, right? Because nothing's changing it. You're always gonna have 5 volts here, right? But now that we added a resistor, something's gonna change, right? With the math, we have V equals IR. When we put a value for the resistor, the voltage is gonna change, right? Earlier, when we have, let's see. Yeah, that's right. Yeah. So what happens here is that once we measure the voltage at this point, so you take two probes and you stick the wires like here and here, you should measure a different voltage value at this point, right? Okay.
Okay. So what we'll do is, oh, okay. You can either use the actual what we're proposed with these female banana plugs to these little probes over here, or you can also actually use your banana plugs to alligator clips if you want to do a more like in-depth analysis of each of the connections themselves. So for this, I'm going to use the alligator clips because I find it a bit more easier to use with the breadboard itself. So what we'll do is we'll unravel our banana plugs. And then on here, we have 3 different connections. For our purpose, we're going to use the red into BQMA right here. And then our black into the common ground. So this will fuse us to the normal operating with a fuse of 250 milliamps. So, okay.
Remember that the positive, I said earlier, red is positive and black is negative, right? Hopefully there's a battery. Is there a battery there? It's like random.
It should be. If there isn't, is there a battery?
No.
Okay. So just, you guys can test to see if it's on by spinning it. We should turn on to see something. Yeah, okay, cool. All right, just turn it back off for now though. So then in our alligator clubs on the red one, we'll put a red light color. I can't see if it's red. So this is red enough for me. So I'll put in the red. And then in the black, I'll choose black. Yeah. That way I know that I want to switch, don't want to check the proper orientation. Okay. So now we have these 2 plugs here we can use to measure it. So I'm gonna do is I'm gonna first turn off the system for now, just so I can plug it in without any interference. So we want to check the voltage of the across the 5-volt battery, right?
Yeah, you can do 5-volt battery.
Or do I across the resistor? All right. So first is gonna be across the 5-volt battery itself. So across the entire circuit. So put the red in the positive bus line. Oops. And then the black in the minus bus line. All right. And then, so if you turn right here to our, there you go. Okay, now let's go to our voltage. So there's 2 different voltages. We have voltage with a solid line with 3 dot lines on the bottom, and we have voltage with a little squiggly line. So our circuit here is DC, which stands for direct current, which means we have a positive, a main positive and a main negative. So that's the solid line with the 3 dot lines on the bottom. So we'll choose that. We'll go to do 20. So and we'll go to your onto the 20. And then if we turn on the power source, we'll see we have about 5 volts running on right now, or 4.98 according to our multimeter. It's flipped. So yeah. Does everyone have 4.98 or so on their battery? So here, let me switch this real quick. Oops. Oh. All right. So again, we click it on. We'll see that is 4.98. Are we all here? Where it's 4.98 on it? Or 4 point something? Should be like 4.9 something. I'm gonna turn it off right now so I can conserve battery. So you guys see it? That's good. So yeah. So with these ones, we use this and right here. So you got red and black. Now you can with these ones, use both right here. You can use but for our case, I want to use a ground plug. There's like a black plug on the other side. Black one is on. Yeah. And now if you have your red as your positive, okay, go. So turn it on 20. Okay. For you, your red button line is on and your negative. You never bridge them. Okay. So once again, we find that. There you go. Go ahead. Oh. Oh. Let's see. So the big is good. Oh. Once they what you do. You missed it. So let's move on to this view. Yeah, I think it's just but I already mentioned it. I know.
It's broken. Oh my god.
Okay. Is everybody else good? Okay. So let's measure something else. Let's measure the voltage over the resistor. Okay. So we're gonna do is with the two probes instead of here. We're gonna put it right over here. All right. So back over here, I'll take out my two leads here. So the positive into the positive one in front of the resistor, and the negative right behind that resistor in front of the LED. So I just put the leads of the multimeter, the positive one right over here, and the negative one right over here. That makes sense? So now let me turn on our multimeter over here to 220. Turn it on. It's reading 2 volts. You guys can't see that. There we go. Yeah, it's not polar, but I just do this because it'll be easier to it'll be a negative value. But yeah, so this one reads 2 volts, 2.13 volts about, or 2.15 volts. So let's see. There's 3 volts. Yeah. Wow. Which one did you use? 2.33.
Oh, that's why. There is nine.
He's there. And what use 5 volts there? 3? Am I the one getting 3? 2.13. Okay.
That's my friend.
It's probably tolerance of the resistor itself. Because if I measure the
What did you get?
I got 2.13.
2.12.
2.13, 2.12.
They're getting 3. Like 2.9. Okay, but 5 is using 5 volts, 2.3 volts.
Well, if you use 3.3 volts to be extra, it would be less than. So it's just tolerance of the actual resistor itself. Because yeah, it has like a plus or minus 10% tolerance. Probably.
It's like 1%.
10%. So, anyways, that's how you measure the resist. So let's do one over the actual LED itself. So again, take out your leads. The positive one right in front of the LED behind the resistor. The negative one in the negative bus line. And then let's turn it on. And we see 2.84. So that's where I'm getting my 3 volts. So 2.84 is for my LED voltage. So
Right now, that's measuring the voltage between the LEDs. Yeah. So earlier you measured only the resistor, and now you're doing the.
so then what about 2.8 volts or so? I probably got the inverse. So I'm assuming everyone else got 2.1 something for their voltages over the LED. Is that correct? 2.8, yeah. 2.1? 1 point. Nice. Okay. One thing to note is, so what we saw was at the start of our, when we actually measured our voltage, right? Our total voltage here, right here, that we first found was about 4.9 something, almost 4.98, right? When I measured it at the resistor itself, I got about 2.13, right? And then the voltage of the LED, when I measured it right here, I got 2.84. So if you calculate this, it should be close. If you add these two up, these two voltages up over here, you should get close to your total value over here. And that is one aspect of this circuit right here. It's called a series circuit, which means that all the components go into each other. So you see the positive goes into the negative of the positive of the battery goes into the positive of the resistor. The negative of the resistor goes into the positive of the LED. The negative of the LED goes into the negative of the circuit, right? So it's one series of things. So this is where the current will stay the same, but the voltages all should add up to each other to the total voltage. There's no problem.
Because your potentiometer is out.
Yeah, I'm getting about 4.97 is my total voltage here. So about 0.001 volt. 0.01 volt. All right.
So that's why
Okay, and then which basically means if you put the positive in front of the resistor and the negative after the battery, after the LED, what you'll get is that total voltage of about 4.98 or so as well with the total voltage. Okay. So are we all good?
It's because okay, well, your LED died.
Already? It hasn't even been that much time.
It's because it's the value.
Oh yeah, make sure your resistor values are correct because back in high school, my friend put well, we needed I think a 10 kilo ohm resistor, or so 10K with the ohm signal, and he put 10 ohms. And so what happened was,
It's basically that math.
yeah, so according to this math, so basically what happened was that resistor exploded and we got smoke and burnt hair smell all over the room.
That
So
smells good. What is that?
no. All right. So I'm going to start. So let's take another one.
I think it works.
Yeah. Does it work? What do you mean it doesn't work?
No, I think oh, the red one is broken.
Broke? Let's see. Oh, I know why. There's nothing in there.
Oh, yeah.
Oh, okay.
Yeah, there's nothing in there.
Yeah, I just looked at that part. Like, what?
Yeah.
We'll get you another bed first. There's nothing in there.
Why would we show that?
It's missing a plus line.
You can show that today.
Yeah. Also showing how.
Hardware now.
I have 200.
No. Okay.
What, 10 columns?
Oh, yeah.
So right now is so just think of the
No, actually. What difference is that?
okay, so earlier
Oh,
it was
it's half a minute.
resistor and unit, right? So at that point at the resistor, it is 30, right? Only that section, only that section. And then I have to measure the LED light, which is a second part of that, right? So when you did that. you
What it now?
measure-
We're gonna use two switches just to see what happens, okay? So we're gonna draw first the main power here.
Right?
Okay, so our 5 volts is gonna be our power again. We're gonna go into what is a slide switch. So I'm gonna draw a simple diagram of a normal switch. It's not a slide switch, but basically, when you're gonna put the two pins together, they should connect these two. They're closed circuit. So how a switch works is that it'll leave it open circuit, so the current can't go past this wall right here. All right. And then after this, we're gonna create a
Then
push
together-
button. So we're gonna
So
do
that's kind of what's happening. So if I take this here and I put it.
and then I'll do
then
resistor
and
and to the LED.
yeah, and the side comes from
And then
whatever input, right? So that's kind of
okay,
so if I were to put it
very simple. Just two different type of switches that you want to do. All right.
right,
So our first switch is gonna be the slide switch.
but the value individually. will not-
So we have here is one of these right here. You can see them. We have 3 connections, okay? So how this works, I'm gonna erase that out here. We have the switch here. A little here. So at any moment, always 2 pins are connected, okay? We either have these 2 connected or these 2, because what this switch is it carries a little tab like this. Okay, so when it's at the bottom position, the bottom pin and the middle should are connected. When it's in the top position, the top pin. All right. So to wire this one up, what we'll do is so the middle pin is shared from everybody. It's known as a common pin or the common ground. So we're gonna put our ground pin, so our negative, negative pin, or right there, and then we'll put our positive right here, or 5 volts. Okay. And then for the other one, do you see? Okay. And then for the other. The other switch we need is the tack switch. You guys remember? Then we'll push button. It has 4 leads, like so. So inside of it is just a little this. And the one right there. So the left 2 pins are connected top and bottom. The right 2 pins are connected top and bottom. But if you press the button, it'll go across to the other 2 pins. So actually make nothing to happen. We'll keep our same circuit here that we have over here, just a little different. So I'm gonna turn off my multimeter first and disconnect it off. We'll keep our resistor and LED still the same. So I'll put the positive onto a different row. So we'll go right here. And then, so we want it to connect to, let's see. We'll put it like so that the middle pin of the switch will be in the same row as that positive wire. So I'm gonna put somewhere else, okay? So the positive red will go into say my number 9 for my row. Then the middle pin of this switch will be in the middle of that row right there. So then when I switch it up, it'll go in the positive one on row 10. So it's a little hard to see. Alright, I'm gonna see if you can just. Alright, I'm gonna disconnect my power source. Just so you can see. Okay. So if we can show you. So what I basically did was this is gonna be like so. I don't know if you can see, that's way too dark. This. Let's see it's a light bulb. Okay, wait. And there we go. You see the pins or no? Yeah. A little hard. Okay. But yeah, so the middle pin of the switch will go into the same row as the positive red wire. Okay. And then when I want this to, when I switch it upwards, it'll turn everything on. So the top pin will go into my push button. So let me get my push button out, which is over here. Okay. And the push button can actually just sit in the same area as the on the switch. All right, so I'll be in the center. Oops. But that bottom left pin, so if you look at the schematic, the drawing that I made of the switch, it's kind of like this, where it's rotated. So the bottom right pin, I'll show up a little higher. The bottom right pin of the push button is connected to the top pin of the switch, or the leftmost pin of the switch. And so what I'm gonna do now is use a jumper wire and put the leftmost pin, left bottom pin, into the resistor like so. So now we made it basically a two-step authentication before this LED turn on. We need to first turn the switch on itself, and then we have to press the button to make sure it actually turns on. So let's see if this works. So what I will do now is put the positive and negative onto the breadboard in this corner. Turn the power on. And then so if I press the button right now, nothing happens. But if I press the switch up and then press it, it turns on. So if I turn it back off, then nothing happens again. All right, so I'm gonna go around and help. Yeah. So I want to just stop my drawing with them. So what we'll have is our positive wire will first go into, so we're gonna have 3 pins for our 3 pins for our switch here. Right, this is the off state. So our positive wire, positive 5 volts, will go there in the middle pin. Then it'll go out and into my push button. Its legs are like this right now because mine's kind of oriented a little bit differently. But it'll go into this bottom pin right here. And then from the top over here, it'll go into the resistor, into the LED, into the but make sure that you know that the orientation of my switch here is when the leg is taken out this way, so that when you press the button, it'll go diagonally down. That's kind of our switch here. In power and power then.
So the reason there's nothing on, see the switch, there's nothing on the last one, it's because it's basically like turning off the switch. Okay, so once you switch it up, that's when the connection. Find a full push button.
So in a way, if you think about the logic there, right? This is like an and kind of thing where only if the button, if you send it, if this is on, then doesn't matter if the state of this or this is on, then you can use this button. Otherwise, you can't use this button. So this is like a major important step for the logic, let's say. No, but when you do have this at 1, then only you can use this. It's like a nested if thing, and if within another if. Yeah. Otherwise, it will happen. Now you could do something else, where you also have the bottom one over here, something completely different. Let's do that also. So what we'll do now, we look more complicated here. We can do a. All right. Does this switch over here actually has 3 segments to it?
No, it's good.
So let's do.
Is
Here.
it-
I'm gonna break this off over here. So our main switch here, positive, goes to this one and this one, right? At the moment, this one goes into the tact switch, which I'm gonna put it as this. And now it goes into the LED, and there's resistor as well. And then it goes to ground, right? But if this is right off though, if this full circuit off, we can do a separate one where let's say we have we've got another LED. We'll put this one with a little bit higher resistance of let's say what other resistance we have. 1K? 1K. Oh, actually, we use the potentiometer for this actually. That's good. We use the potentiometer for this. Okay, so this one here will be our 10K potentiometer, which looks like this. And then this as well.
Oh, it's already.
So it'll be a little complicated here, okay?
It's 100 and it's 100.
Okay, 100, okay. And this one here will go into another LED, and that will go all to ground. Looks complicated, I know. So, but so we'll do this one. Okay. So this is a really bad way of making the schematic, but good enough. So let's do this. We already have the first half of it. We've got to make the bottom half of it too. So let's make that one. The potentiometers have 3 pins. So they look like this on the top. And then they have a little arrow, little dial on them. They're blue. And on the bottom of them, if you look at the side profile, let's say, they have 3 pins. All right. This is power. One of them power, one's ground, and one signal wire. So power, ground, signal wire. Okay.
Oh, you're going back here. Sorry.
Yes. All right. So let's grab our potentiometer. It's going to be in this blue bag right here. Right here. So we'll grab it out. And there it is. And yeah, okay. A little blue. Okay. So you see there's three leads on them. So what we'll do is on the flatter side, there's like 2 leads on the same row or column. So put one of them onto the backmost wire.
Did you
Over
show them
here.
that there's 1, 2, 3 on?
There's.
Yeah.
No.
So on your potentiometer, there, if you look closely,
Okay.
there is 1 and then 3 on it. So 1 and then 3. It's on there. The number's on there, but like it's very, very small. And it's very hard to see.
All right, we'll put it, let's say, right over here. Okay, right over there. We'll grab one wire. And they'll feed it from the bottom wire of the switch into the top right here. It's a little hard to see, but when you put it down, there should be like 3 segments, 3 holes I should be able to like see next to the actual piece. And then we'll put the bottom into ground. And then we'll grab, let's say, we'll grab a white LED or a clear one. that one positive from the middle pin here all the way over there. I know it's really crowded over there in that corner. And then last but not least, I don't have enough wires. Okay, I mean, okay, you can use you don't need a multimeter as much right now, so we'll take out the wires from them. And then just put the minus of the LED into ground as well. All right, it's a little hard to see, so I will first show you how this works, and then I'll go and help you guys, I think, okay? But if we turn on our circuit right now, it's not turning on. I wonder if it's okay. You see right now, with our switch on the off position, we cannot turn the blue LED on. But if you rotate the potentiometer, you see the LED getting it's a little bright right now. If you turn it more, it's brighter, very bright. Go all the way down. You can even turn it off. All right. But if you slide the switch again back up, oof. This is really crowded. I should have got through. This indicates I'll press the button. So this one now, press the button. Okay, I'm gonna remix the circuit so it's a bit nicer to see because it's a little bit crowded on the corner. So again, we're gonna take it out real quick. So this switch here, I'm gonna just move it real quick to another corner, another path. So that'd be positive. Go in the middle. I can put it right here, maybe. Put it right here. Okay. And then from this corner, we'll have this switch. Right here. And then this one here will bring down LED. You can go here. And the bottom one.
The middle of potentiometer goes into. So the potentiometer, the middle one goes into the positive side of the. Yes.
Okay. Let's use again. This one.
End of the switch.
There we go. Okay. Need help?
Yes. Alright. Maggie said that this hearing about the right, I think my father so I have a something about this. So this is the switch. So where do I have the switch in the right? And this one goes to the bottom.
For the middle one is the positive. The top one here will the switch. And then you have You don't need to allow practice work.
Yash, why is my not turning on? The bottom, or is no? Oh, oh no. It took off for a second, right?
Okay. You can ignore the lady.
I don't, maybe not. Okay, it turned off for a second and then it died.
Yeah, something like I don't do good to Steve to turn off the lady. Yeah, I don't put a register picture from the thing.
Right?
Yeah. How about you make it?
And we blew it up again.
Yeah.
Yeah?
That blew it up again.
Wait, let's see if I blew it up. Wait, okay, this one. Josh,
You only need one.
So we should have a register before this one or after this LED right here to make sure that nothing never shoots it. Yeah. Second add it.
Oh yeah, I blew this resistor. This probably be like, yeah. So I think what happened was we put too much power into it.
All right.
But it didn't blow up though. That's sorry, sad.
I see. Where are we?
Well, now that's the reason why I kind of have to do this thing, is to like.
Yeah.
So earlier we put the resistor right here.
I'll do it first. On the bottom. Bottom.
Okay, it shouldn't blow up now. Yeah, so it should not to blow up now. Let's see. What do you turn on? Let me make sure. Okay, it should have blown up. Yeah, like
Yeah. So
yeah, it
what I also should have added was right here. Another resistor right here. Oh, either or. Well, you already know travel.
This, you can put this across here. The LED light, you can see it change as you turn this on. I want to make sure it didn't blow up on you guys. Huh?
Oh, okay, sorry.
Well, I was supposed to do another ticket, but.
We got this one campus Maggie.
Right after the LED.
Yo, it's boards on yellow LED.
That's a new version.
Shouldn't be taking the back after the issue. I think it's something like. Awesome.
Okay, it should.
I don't.
So this one is fine. But again, everything is stable.
The wire.
We remember.
No.
That means that when you have it at zero, it shouldn't turn on, so it should turn on once it's. So now it's at 10 volts.
Now turn the power on. Now. And then. Okay, then.
The reason why
Put the
it
better way.
limits at 2 is because there is.
No.
And then this also has resistance on it. So just think of this as this, but like from 0 to 100. Okay. Okay.
Everybody got it? So I didn't put a safety on mine. Hopefully we've learned. So make sure you have a resistor after. Let's go. Okay.
And it worked, and then we can stop.
Yeah.
Okay. These are. Okay. That is something really cool with capacitor. Alright. What are capacitors used for?
Capacitors are used to store energy.
When would you use them?
Oh, we can use it for, charging and discharging. Charging.
So, You can use the wait, no. Okay, I'll do something else.
What?
Wait, okay. Okay. So when I first experimented with capacitors, I used them as a temporary power supply. We can make one about that. So what we'll do is let's make a simple capacitor circuit here. Now these are really small capacitors, they won't last that long. But we'll do anyway. So we'll have. So I'm gonna draw the DC power of something else now so far. Like this is also going to draw DC power. So our 5 volts. And we're gonna do is we're gonna use this our push button, okay? And that one will go into
Josh, I don't think the capacitor
I know.
is not. Do you know?
I don't think it's okay. But we'll do it anyways. If not, I'll put it in parallel.
Okay.
So let's first make our charging circuit, okay? So we're gonna have our I think real quickly about this one. You want to create a charging circuit? Make it so that when you push the button, it'll turn one LED on, charge the capacitor, and then explode.
I don't know how to do it.
But I want to do so the one LED turns on when you charge it, and another LED turns on it's charging.
Charging and okay,
One
so
LED for charging, one LED for discharging.
so this one is going to be connected to the capacitor. Um,
Ready? Discharging. That's charging. That's discharging.
open will go right there.
And then discharging on the if you go from here. So only turn one on discharge. Okay. Honestly. We can do.
Oh, the switch is. The switch is. It's only, I only did it with one LED light.
That's okay. So we'll do that then. So we'll have this right here, like so, and we'll have one power capacitor here. So these one right here are called electrolytic capacitors. So they're polarized. We got to make sure that our positive is to the curve on top of the bottom. Yeah, but is the negative one straight line or the positive one?
The negative one is. The long.
No, it's for the schematic.
Oh, I think this is, huh?
For the schematic.
Yeah,
The curve is positive or curve is negative?
oh, it's this one and this. Curve is like.
Okay, that's
Yeah, curve is like.
yeah. So, what will happen here, if you look at this real quick, is when the battery is protected, if it goes down, it will go through the capacitor, charge the plates up, and as well as to go for them with this LED turn on. When the switch is off, then it'll power everything instead. Thanks. Let's make this real quick. So let's turn off, let's take off most of our stuff here. All that hard work for nothing. So we'll leave our LED here as well as our push button here. We don't need our light switch anymore. All right. So our power has to go into the switch. Put it right here. And then these one have to leave. Okay. So actually, what we can do is we put it right up here. Since our switch is that these left are for me are left, yeah. The left connections here are basically one wire. We can put the capacitor as well in that same area. And we can put it into ground. Yeah, well, once I just give me a second. All right. So this is our circuit here. Oh, that's so very blurry. Okay. So what happens here is when you put power and ground into this, it will first flow into, when you press the switch, it will flow from the power into the resistor and the LED as well as the capacitor. And then when you remove the power, it should be able to like sustain it for a little while. Okay. So I'm gonna put the power and ground into the bottom rightmost leads of the switch. So our positive wire goes into, so our negative goes to the ground, our positive one goes on the rightmost, turn it on, press the switch, hold it for a bit, and then we turn it off, or it's too late. It's too small. Way too small. All right. I thought it could at least last a little bit. Okay. Since it's too small. Huh? It's 10 microfarads. It's very small. So do you think, okay, what we'll do is we're gonna use that one should be like 0.1 or something. It one's a little, I can't, that's 104 it says on there. It's the 0.1, I think. So what we'll do is we're going to make our own large capacitor by making a bunch of these in parallel. So let's see. Do we have enough wires? Okay. We're gonna feed this part right here. Up here. This one. And then there's another one. I'll go. So feed it right here. Right here. This positive one will go into positive minus here. I'm gonna grab all of them and see what happens. Another one here. Positive 2. I'm gonna put like 5 of them and see what happens. Yeah. You don't be too much? Okay. Another one. Actually, what is like? All right. I'll make this a little bit easier to see. I'll put like this. So, another one here. Okay. So we're gonna have 4 of these capacitors. And then, so let's see what happens now.
So
So we're turn on the negative and the positive. Turn it on. Power. And then disconnect. No. Positive, negative, negative ground. No, it should feed it back. Okay, let's see the multimeter. What's up with this one? So, what's the voltage on this capacitor over here? Yeah. Is it really too small? There's 2 volts on this right now. Okay, these are kind of all charged, so they should be able to go through, but they're not going through. That's because, see, minus here, positive through here. LEDs.
then that's gonna fill it up, right? So that's what I'm having.
Okay. Positive is negative.
Oh, yeah, it's an eyeball. It is working. Okay. Yeah, even with an eyeball. This one, I think I have to change this one.
Hey, Maggie. Maggie, get over here. Come here.
Yes.
The capacitors are all charged, but they're not discharging.
Wow. Very, very cute.
Like if you look at the back one, that one is at 2.15 volts right now. I'm assuming all of them are probably at the same voltage right now.
Is that discharging? Where's the discharge right here? Like point of discharge.
I think the LED. So negative. It's negative of the LED. Positive. Positive goes to the resistor. Goes to the LED.
Wait, why is this positive? Or why is this negative?
Do you know where should I put it then?
Oh, it's in series. Should be discharging.
Well, we can get real good now.
I have to set the idea for it's the capacitor.
I think it'll work.
Huh? You still think it will work? I don't know if that's how it works, my friend. Okay. But yeah. Is anyone doing ECE? ECE? Are you guys ECE? You guys not ECE?
I see.
Is he ECE? Are you ECE? Huh?
Oh.
Yeah. Because these come in really good handy for a class. Yeah. Yeah, this is like,
You should have to talk with that.
yeah, I bring it to class sometimes because it's like so useful.
I see how much current this one has. Is it like, is the on
Yeah, you
current?
can test anywhere. What's up?
What is it? One more
You
test.
guys want to do engineering? What did your parents tell you?
So.
I was but I was thinking better, like if I do a minor with, you know, that's a certificate that they offer.
I think you should just get your degree and get out.
Electrical.
Yeah, just get your electrical degree and get out. You don't, it's unnecessary to get the other stuff. And that's in my opinion, but that's also what my professor told me, so.
I think I know.
But me, I'm only getting electrical and I'm leaving. When you guys reading? This spring. Congrats. Thank you. Thank God. Yeah.
But I feel like in the certificate, they teach you a lot more. Like,
Really?
hands-on.
Yeah, that's.
Yeah, that's why like I'm making this. But I think it's electronic, electrical and something like that, but it's a certificate, but they do a lot more hands-on. Like at school, yeah. Is that everything in second floor? That's what Martin, that's what I have. Okay, yeah, I'm sorry. Okay, that's what you said. Okay, so I'm gonna like Martin, this is basically what, you know, when I use that one is everything that's really well. This is like a big learning piece. They do more than they. They were saying we would be able to set the more hands-on. It's okay, and then when I was the stuff, and I said, yeah, hold it. Yeah. Obviously, so if you come down, if we go in depth, and I didn't like any. But how about that's what I mean, you don't have to do again. Cause you have. And you have. Yeah, because we could do that. Yeah. What? Yeah. But it's okay, you'll be fine. Sure. Are you guys gonna math? Especially if you went out. Perfect. Yeah, perfect.
I'm not gonna.
Well, it's a lot easier. Because I at soccer. I was so bad at soccer. Cause I wanted. And then obviously my history was like also down. My history, my social science was like really bad. And my English is pretty bad. So. Your English is fine. No, my English is bad. No. Your English probably or your English writing? My English writing. Oh. Yeah, my English writing is really bad. Well, you're not English. Exactly. That's why I can't do anything but math. So. Yeah, I would love to be. Science. Huh? You don't like regular science? Computer science? Like regular science, like. No, who the hell likes science? I love science. I love life. No, I hate science. Like, what? This one, you must memorize. Yeah, I did a lot of like biology and advanced science from them. So that's like more natural speed than here, I guess. I only do one biology class and that's no, I love it, right? Like, I don't actually like just so what works I think okay, so if the 5 volts, okay, how long like I don't know if I didn't think. So like 5 volts. Where is the 5 volts on your bed office? Where the plug is, okay? So just follow the wire, right? So this one, the push button, okay? This side is separate from this side. When you press the button, it goes through here like this. Okay, so the positive goes to positive, and it goes through one side of the button. Okay, so connect one wire from the positive side to one side of the button. And so if I'm doing the same thing, right? Now the button is on, we have the button, and on the other side of the button is this side, right? So it's on the same like side of it if you look at it, but it's the one next to it.
Yeah.
So you happen to see
So that
there
one's
is no,
connected
there's no.
to,
Yeah.
let's
I,
go
it
down
might be
one,
too
we'll
low.
do
Might not have enough current
So now this one is
to turn on the
connected,
diode, you
the
know.
wire to the resistance.
I'm thinking
So do you think
And
like
so connect this
they have to be
wire.
in parallel, right?
for a higher capacitance,
Huh.
but I think it's not enough current. So I'm thinking, what if I put,
Can we? Okay, I have more capacitors. Like, if you try something bigger, like, do you think?
maybe, because I think it's not turning on the diode. So I'm thinking right now, I'm gonna use the transistor here to kind of switch on and off the, if I use this,
One of these, I don't know.
No.
This one would be big enough. No, actually, this one's a little.
I'm gonna use this transistor here to kind of turn on the signal using a capacitor and see if that will be the one.
Mhm.
So that one I need to do.
I even put 5. It doesn't.
0.8. That's enough. So the base is D. That's that. I'll turn on I'll turn it on. Right. And then we have the
Or the
LED. So this one right here.
remember that this
And then we'll have this one
the wall is negative, right? And then this
right
is positive.
here.
So the long side has to be
And we
connected
have
to
this one
this
here,
and then this one goes to
which will come from
negative.
here. No, this is positive, so from here to the ground.
One end and that's the other end.
That's the ground. No, this goes down. And then power from 5 volts.
There you go.
5 volts.
You're still taking care of us.
And then
You're far away.
from here, 5 volts of this. And then ground is that. And it's on.
Mhm.
What is the opposite one maybe? Okay, switch.
So, okay, what would be the capacitance that you need to actually to discharge, to bleed it to the LED?
I honestly don't know at the moment.
No.
Not current though. Why not? That's because this thing is twice still has enough current for 0.42 volts left. So I probably can't even turn on the
Enough to turn it on?
it's not enough to turn
No,
on.
it's 0.7 volts, right?
Yeah, it's not enough to 0.4 said I am, but so let's make sure I think I did this one correctly. Right? So if I turn this one here, there. That should turn on that. Nope. Did I blow the PMT2 here? Connector.
So now you have, what we did, is we put the negative, this is the negative side, right? Yeah. The negative side is inside the negative port. So now we just need to connect this positive side with the other end. So when we follow, let's go back this way. So we have the positive and it's connected to the same wire as this one, right? So connect this part to this switch. This switch that we had earlier. Oh,
I lied. It's the opposite way.
This is another. Oh, okay. Yeah, we don't live with the thing, it's not the same mother. We just have to take one.
Is that you connect it?
But if you're using it, she's
Right
here.
Yeah. No, there's this part and then there's this part of the resistor, right? The front and end.
Yeah.
You put it in the middle where it's between the LED. You want it to put in the same row as this wire, right? So it should be at the same as the front. Okay, so this is connected to the button, okay? So it's that. Number one is connected to the button. So you want the pathway to be connected to the same row as the top, right?
Yeah.
So what the capacitor is connected to which and the front, the first part of the so you want it to somehow place in the same row and same connection. I love it. So. No, you don't want to put like here.
Instead of that, we use a capacitor.
So why I got 25? Because this one is on this end is at pin 25, right? And then the end of this resistor, the front of it, is also at 25. And then going here, it should be at 25 too, right? So this whole thing is the same wire connection. So all of it is connected together like that.
One this
Right.
is.
Let me try something. Instead of a capacitor here, you could put a resistor and LED light, and both of them will turn on at the same time. All that.
Yeah, but I just want to figure this out now that I'm doing it.
After you get this one.
I'm.
I blew my.
Sorry, those are. So, charging, 5 volts. Then you. Right, that's why, that's not enough power to the LED light, but I don't know what it's all. So. What's the point?
I think.
So the point is. So. Oh, these guys. Be there. Then. Okay, so, let me go. So I have a capacitor, same setup, just different way. Right?
right now, I am. Okay, it's hard to know the
Oh, now you don't know. Which one is which?
I'm dumb. No, I know which one is which. I just took off the entire all the pins.
No, but that's why you use that.
I know. I thought I had it in my hand.
Oh, yeah.
It's okay. I got this.
Just the parallel circuit. Once I, it don't have to be an hour.
Thank God.
And right now, the power is still.
Okay. So, my theory is
Okay.
we use this. We use enough
Is
current.
that what is a JFET?
Hmm?
JFET?
This one is a I don't know. It's the PN2. The PN222. The PN222222. So, if I plug in power and ground here, let's say, it will also, so power and ground will go here and also branch off into this right here, which will turn this whole thing on and power this. Bye. But if I remove the power, it should be able,
Even if you have a big enough capacitor.
so that'll go there. Okay. Actually, I go from here. Okay. So that will be on the same as, say this right here. Yes.
So that's the.
No. Okay.
How
So this, when this sends power, it should send power. Well, basically, it'll send power to the collector here. Yes. So we still have power and ground on this side. The power will still power the power over here. And then the grounds are still connected. So the ground here and the ground here are connected. That way. And so then if I send power here, or I press the button here, it will also, I need power from the button signal wire thing. This side here to also power over there. Okay. Oh no, sorry there, sorry. Okay, so main power and ground are gonna be here. Then power will run. I press the button. This will, power from here will go through here. It'll go, I can put right, I'll put right here. So it'll go through here. I press the button. It'll the signal wire here. I'll go to there. And then signal wire here will also go to charge these up. I let go, just stay on for a little bit longer. Okay. So power this one. Yeah, it's a little bit. It's a little. Versus if I turn this off. Yeah, it works. It works. It
Okay,
works.
with more capacitors.
Yeah.
Damn, bro.
Yeah, you know, a lot more.
Yeah.
So I think AMS is more of like the reason why it's important. And voltage is. I think it was for reason how shorter resistors are going across in parallel. Like you have to have both current and.
Okay. Turn this on.
Yeah.
It's a lot.
It's better. You need more capacitors.
You need a lot more capacitors.
But it's showing, you know.
Maybe do I need the do I need this though? That's my question. And what if I just take this out?
Ever tried?
Which means that I need to, I mean, it'll just be a simple connection from here to here. Okay. Yeah, it does work.
Yeah.
I never needed the transistor. Okay, cool.
Yeah.
Okay,
You just
cool.
need more capacity.
I see my capacity.
Yeah.
All right.
You can put more capacitors in it. You have this row.
I need to do this over there. Okay, and then this side as well. Okay. And then so this versus yeah, okay. All right. Maggie, it works. But okay, it's too small. The color too. I put a bunch of them in parallel right now. See, because capacitance, it still can't do it. But what you will see, what you cannot see. Oops. Okay. This is the circuit that I created right here. I'm gonna take off the wire for now, okay? So this is a normal button, a push button right here. So if we press the button, you see how it's very snappy, right? When you press the button, it just quickly like turns on and off, or yeah. But if we have these capacitors in here, and we hold it to charge the capacitor, and we let go. Wait a minute. What it was working like a while ago. What changed? Oh, I know why. There we go. All right. But you see, actually, you watch. Okay, if I charge the capacitor right now, they should hit 5 volts or so. And then if I let go and charges, you see how that clearly went? It fluctuated right there. Saying grab power here. I know it's not good. It's not healthy. I know. Okay, so right now, we're charging the capacitors up right now. No, I don't have it on right now.
Okay.
I'm seeing the light right now. Okay, I charged the capacitors right now. So they're like, so if I just let's put it right here, it quickly turns the LED on, and then let's dims out. I seen a lot more capacitors, but if I hold this and let it charge, and then you see how it kind of slowly fades away instead of snapping away. So if I take this whole thing out, it still snaps on and off. There's no fade, but put this in, and now we have a fade because it slowly discharges the capacitors. I can put another one on, one last capacitor on, or two more. I'm just adding more capacitors for fun. If I add enough, it should be able to charge the power for a while. Yeah.
Oh wait, is the what's this on the side? Like the
These?
plus minus, like
The bus line?
the bus line, is it all connected?
So the entire thing, the entire row, the entire column.
Oh, okay, because this one had like it was like separate by 5s. So.
Yeah, so you have like these are long bus lines like that.
Okay. But it's thank you.
What if I? The negative goes to negative, positive goes to positive. So I want to use it as a battery basically. So I'm gonna try something really cool and see what happens. Yeah, I'm gonna see if I can maybe keep it on for a little bit longer. Maybe a lower. So That's not working. That's basically no resistance. Now if I maximize the resistance here,
Should I go get boba?
let's go. So it does turn on. See, it's staying on for a while, but I think it's a lot dimmer now, but for longer. All right. Oh, almost there. Means much. So if I hold it and charge it with the resistor value, it should keep it on for longer at a lower voltage. So it'll be won't be as bright, but it'll stay on for a longer time.
Yeah.
Yeah. There you go. Mm-hmm. V equals IR, guys. Ohm's law. Okay. Man.
You guys can keep everything basically besides the multimeter and like the clamps, the wire cutters, yeah, the tools. Basically the tools, and then you guys can keep the power supply.
If it's 3D printed or it's part of a circuit, it's yours.
So yeah, so one of these, the power supply, or no, not the power supply. You can keep the power supply.
The component gauge you can keep.
Keep the stuff. You can keep these. The power supply you can keep. Turning this again and the multimeter. And inside the multimeter, it's only one set of wires. So in your search, in your box, you should have two like alligators in it. Oh, it's like it makes you go different. Yeah. Oh. Huh?
Hmm?
Can I buy?
Yeah.
How much?
I'm trying to think right now.
$100.
Your entire tuition, actually.
$100, but only $5 goes to Hyperloop, and
The rest goes to
not
me.
the rest goes to the person who sells it. So do you?
Can I get another for this?
Probably like just like $5.
$5?
I think.
Let me go buy.
Okay, $8. $8. $8. I think $8 is really
Well,
good.
she's a Hyperloop member.
So $5. But for you, Maggie, $10.
$8 is like almost the price of a kid. Like $8 is half the price of a kid. Yeah.
Yeah. Half that's just on that. I think $5 individually for this. These are not, not for sale separately. Not that label.
For individual sale.
Yeah.
That's what it says right there?
No,
No.
I can make it that.
Oh, okay.
Right. What did we not use? We didn't use the diodes and the. I made these two basically useless to cut into each other.
You didn't use the turret crosses, did you?
Huh?
Or those?
I don't have change.
Might have changed.
Thank you, Alex. I should probably stop recording, or else I'm gonna get all these memes in the actual thing too. It's not very helpful. Stop recording.
Like this?
Why stop recording?